and that's I think they are given for wheat. This data is for wheat. They are denoted for multiple, and mm, wheat have wheat is polyploid, and we will get multiple type of band. Like here they mention AB plus AA. Here you can see AB plus AA. This is for polyploid crop 12, and ABBB is 10. Can understand or something missing?
Yes.
What?
I believe like HA means is a heterozygous with a dominant behavior. Like HB means it's a same heterozygous, but it's kind of some like a recessive behavior.
No, no,
Not like
It
that.
is something else,
no.
Shravan.
It's depends for the polyploid crop. This part is for polyploid crop. This for the simple
These
A.
two are polyploids, Shravan. ABAA, ABAA, BB is for polyploid.
Yeah,
Polyploid with diploid cross.
you
I
can.
think
They also
AA,
meant
AB,
A, B, A, A represent the two non-separated genotype A, A, B, A,
genotypes.
A, A. You are working with foxtail. Foxtail is polyploid or simple. Hello, doctor.
Yeah, it is a diploid. Our crop
Yes.
is a true
So if
diploid.
your crop is diploid, then you just keep simply 2, 1, 0,
Yeah, that we have followed.
and missing for like X or -1. These
Yeah.
are coding criteria for. And if you have a SNP file like in VCF format, then you can change it to by just like one
Yeah,
click.
that SNP file, it is actually genome-wide DD based.
Yes, yes.
So that it's a SNP file only, and it was converted into A and BH type.
Okay. You convert it manually or using some tool.
No, it is already there. I mean,
Okay,
it
they
was
provide
given
you.
by, yeah, service persons. Yes.
Okay, okay. Okay, if you anytime you have the VCF file, then you can convert it using the Tessel tool. By it will you just need to provide the parent, which one is the parent, just two parent information, and upload your file, and it will automatically within 1 minute or few seconds it will change your file to this format ABH.
Okay.
Now we are going to how to do QTL mapping. First, we need to one. Yeah. This is for this is our genotype file in Excel format, and there are this is the information like our population type, which mapping function we are using. We are using the Kosambi and Haldane, and there are one more is the
Virender,
Morgan.
it was not showing.
It's not showing.
Yeah, it was just your QTL ICI mapping only.
Okay, okay, wait. I will share the file.
I think you have not shared that file.
Okay, okay, I will share. Don't. Now it's visible. Now it's visible.
Yes, yes.
Okay. Like this is the mapping population type. This is our actual file, and these are three sheet. One is the general info. All names should be same when we before uploading the file. This name of the different sheet, and the first sheet is the general info of our population. That is the mapping population type 7 we have, and this is the mapping function we are using Kosambi and Halden are mainly use function for QTL mapping. There are only one difference is the Kosambi use the interference, and where the Halden not use the interference means when crossing when music in music crossing over occur, and Halden assume there is no other crossing after one meiosis, after one recombination. And in Kosambi also assume there is the possibility of another recombination after one recombination. And that is the marker space type interval, or we want to like this is the not given here. Interval means we are give specify the position one position of marker to another is the interval, not the exact position. Number of marker. This is the number of total 117 marker in this file, and the size of population is 180. Now the genotype is 0 to 1 format, and there is no genotype information needed. That is, but we should know which one is the first column, as later we need the same or in same order the phenotype, and that is the anchor information. If you have the anchor information you can provide. If you don't have the anchor information you can give just 0 for all. Now we are going to do ICA mapping, and now it's visible ICA mapping tool.
No.
No.
What is anchor, Virender?
Anchor is a chromosome, means where the SNP is attached.
Okay, it was assigned to respect to chromosome.
Yes.
And okay, okay.
Yes, ask any what
That phenotypic data is
we need.
below.
We need later the phenotype data. Once we first we are creating the map,
Okay,
and in the ICA mapping give the file, and we need to give the phenotype in the same, but orientation of phenotype should be same to this file.
okay. That genotype number,
Yes.
individual number, yeah.
No, there is no individual number. There is only marker name, and but there is no genotype
We need
name.
to assume that B is the individual one.
Yes, and
Yeah.
in same order we need to provide the
Yeah, C
phenotype.
is individual too. Yeah.
Yes.
Okay.
Now visible the tool I say mapping tool is visible.
Yeah, it is.
Okay. Now we are going to upload our file to IC mapping. Just click on file and new project. Give any name to your project, and the like I'm giving the my name Virender, and you can also give the location, but I giving the default location. Okay. Now we are going to make a first map, linkage map. Click on linkage map. Our file in Excel format and select your file type here. Click on this file and open it. Oh, one thing, your file should not be open. First you close all the file if your file is open, and then click again. Then click on open and click on linkage map construction. Type of file, select file type, open it. Now file our appear. First we going to make a grouping. For grouping we can go by the recombination frequency or LOD value, or we are going here by the recombination, and just click on grouping. This is the threshold value, means above 0.3 will be taken consider, and below is consider below 0.3 consider as they are the linked marker. If they have recombination event less than zero point 0.3, then they are considered as a linked marker, means they are present near to each other. Then we can go by ordering. We are going by K optimality. Now, or we can go by anchor order as we are provided in the file, but we are going here by K optimality. You can select this value, but we are going by default. Then window size 5 means it will consider 5 marker, adjust marker. Then rippling. Then this is the output file we need. We can click select all of them and outputting. Our output file will be saved where the we select the our. This is the B file. We need to find this file in where we are given the project directory earlier. We will find that in our PC. If you are selected this by default, then you can find this in the C drive. This is the default in C drive. You can find this folder IC map work. Click on this and the project name I given the Virender, and map rise app file name, and this is our result, and result.bip file is here, and open it. Here, and this screen is visible.
Yeah, it is visible.
Yes, it
You
is
are able
visible.
to see the rise f2.bip file.
Yes.
I open
Yes.
it. Okay, here is the number of trait. If we have the multiple trait, we can select here like one, or we can select two if we have two trait in our phenotype file. If we have three, then three. As many trait we have, we can select here. But now we have only one trait. We select one and go to last of end of this file. We need to paste our phenotype here. Like first column is the trait name, then is the value, and there should be the order of these phenotypes should be same to the phenotype we earlier provided. Now save this file and
Yeah, good morning, Virender. We are not able to see your screen.
oh, but doctor already told he able to see.
We are just seeing your results still.
Your
We are
result
not.
file is result folder is
Oh,
visible.
okay.
We are not seeing what edits you are making.
That's
Okay,
right. You need to again and again share, it looks like.
okay.
Now we are just seeing those files. That's all.
Hmm. Now,
Yeah, now we can see.
okay. First of all, we need to make here the number of trait. Open this file where the folder is in your folder, and here if your phenotype file has more than one trait, like you have two trait, then you select two. If you have three, then three. As many trait you have, you select the number of trait. But now we have only one trait, we select one, and then go to end. Earlier this is like yes, this file is like this, and you need to paste your phenotype here. This is the first column is the trait name. This is the file I took from database. It's a resistance. I don't know which state, which resistance. And the order of this value should be same to the earlier as the genotype we provided. Now you have got and save this file. Getting you? You are getting this?
Yes.
Okay. Now I need to again share.
If it is more than two or three trades means below only
Yes,
the second
like
trade
if
will
we
be
have two like this.
298. 298.
Yes,
Yeah.
that many will like this, like
Okay.
one, two,
Okay.
and we need to modify above.
Okay. That's okay. Okay.
Okay. Now I'm closing this file.
You need to save now before that
Yes,
file has to
we
be
need to
saved.
save. Otherwise, how can
Yeah.
we? Yes. The phenotype now appear here. Now it's showing the phenotype also. And we can see our map. And if you want marker name, click it will show marker name. If you want to mark name on the left position, just select it like this. Or you want position or interval. If you want interval, you can select interval. If you want to increase or decrease the thickness of the chromosome, you can do. Okay, now click on open and then select QTL mapping in bipedal population and select our file. Desktop. Then select big file where big file saved in C drive. I see work map. Open it. Now we have uploaded our zip file and select which like single marker analysis. This is the manual input. This is the LOD score. And we can keep it 2.5 if our trait is grown by less number of genes. Like our trait is grown by 2 or 3 genes, then we should keep a LOD value about 3. And if our trait is grown by multiple genes, then we should keep 2.5. And this is the missing phenotype we want to replace. If our phenotype file have missing type like uh, missing phenotype, then we can delete it or by mean replace or replace by the mean value of all the session, all line. We can select multiple at a time. Click on SMA and then click on here, and SMA appear here, and we can select multiple. First, we are going to analyze only by one. We can remove them. Then click on Start. Our analysis starting, and click Beep. Result. This .qsm is the QTL information or by single marker analysis. Click on this. These are the result. Means trait 1. There we have only trait ID one trait. There's only one. And this is the chromosome number 4. We identify that these QTLs present on chromosome 4, 7, and 11. Total of 7 QTLs. And this is the marker name which are associated with these QTLs. This is the LOD value, and this is the phenotype variation explained by these QTLs. This is the additive effect, and this is the dominant effect of this QTL. Similarly, we can do for other method. Select it and then remove. Select here another and click on Start. Oh, sorry, didn't select it. Okay, now click on Start. Now check again in your file. Yes, this is the QTL information by this ICIM method. Click on this. In this method, we identify only two QTLs present on chromosome 4 and 11. And this is the position of these QTLs, left marker and the right marker. And in earlier files, there are only one marker shown. As it analyzed by the single marker analysis, it's only one marker. But here we are using the inter IC intercomposite mapping, and there are two marker, the left marker and right marker, and this is the LOD value, the PVP, additive effect, dominant effect, left CT, yes, left confidence CT is the confidence means same position starting from and position ending to the
That's CI, confidence interval.
CI, confidence interval. And then we can do for another. We can select and remove this one and select another method, interval mapping, and then again click on Start. If it's completed, we can find. Why our file reduced? Yes, QIM. And by the interval mapping, we identify the three QTLs, and these are present on chromosome 4, 7, and 11. And these are the marker informations, the LOD value, phenotype variance explained, and additive effect, dominant effect, and left confidence interval, and right confidence interval. By comparing all these three methods, we can say which is the more confident, more potential QTLs. If we are finding these QTL in multiple methods, we can say these are QTL most probably involved with this resistance method for resistance. And similarly, we can do for another method. We can also select all of them together. SGM. By this method, we are not identify any QTL. Yes, this method not show any QTL. Epistasis. Interval mapping by epistasis effect. Now it's running. It will, I think it will take some time. This .st is the statics file. We can see the statics of these, like the kurtosis, skewness, standard error, variance, mean, sample size, state name, W test, p value, range, and this is the correlation between different markers. MTP. I don't know what is the MTP, but these are all the resultant file. We can find all these file in our, yes, now it's interval QIM, interval mapping by epistasis effect. By epistasis effect, we identify the four epistasis QTL present on different chromosome only. I think one are present on 7 chromosome. We are earlier identified. This is the their statics means main important is the our input file. If we our input file should not have any space. If it have any single space in anywhere, it will not work. It will show the error during the upload file, and our file should not be open during upload. Just close it if your file is open, and only then it will work. You can find these all these in C drive, result in the C drive, or where you will give the default the directory to save file. Oh, one thing, uh, If you are analyzing one by one, it will replace the earlier result. You can select a multiple together, all of them. Select all of them. Then start. If you do one by one, the file is replaced by the earlier all the file, or you can need to, if you analyze one by one, then you, after one analysis, keep your file in other folder, remove all the file, and it will take time now. If you have any question, you can ask. Hello.
Yeah. So you can repeat everything fast one more time, very fast, right from the beginning, without any pause, like fast forward. So everybody will have.
Okay. First of all, we need to make a genetic linkage map. Just click on map file and upload your file. Open it. File already. Okay. We will select another file. We will select Barley. Open it. Yeah, it's giving some error. I don't know why. Okay, we will make a new project. Already existing project. Do you want to close the current? Oh, after finishing, we can do again. Let's see. Yes, now I think it's completed, and our files are available here. Like QI, all the file which are start with .qi, .q means they are the QTL file, which has the QTL information like this. QTL for interval mapping, QTL for interval mapping epistatus, QIME, QTL for SG, this not have anything, and QTL for single marker analysis. All the file, and you can find all these file now in here. In this folder, yes, all these files are available in this folder. ICI mapping project name, then the BIP, the file by printer mapping, and this is the file name, and this is the result. All the results are here. You can use them. And one thing, the tool map show. And if you want to make like a QTL, figures, why not activated? I don't know why the QTL figures not activated.
We are again seeing only your results files.
Okay.
It is not visible in.
Oh, I meant I got it. No, I'm just looking for how to see on the map this QTL, but it's not showing.
In ICI mapping, I don't think you can see the QTLs on the map. You can just see the map. But for
Yeah,
if
we
you
can see the map, but these are not activated. I don't know why. We can see map, but only in the graph form, not on the map. Like it will show the position in graph. A line will increase or decrease, and below it's showing the position.
yes, yeah, that is right. But
Yes,
on the map you can't see anything. So for that you need to use map chart
yes,
or any similar software.
yes, yes. I know.
And here the file may not be active. If you open that file, you may be able to see the map because your map itself is not active. So your files
No,
somehow they
map
stop.
we can see here. No
No, it's still
problem.
not active. Yeah. So if you
If you click on map, then map file, then it can be activated. You can say map.
it's showing inactive. Yeah,
And
now it is active. See. So that's how if you open that BIP file,
yes,
you may be able to see that QTL what you are saying.
yes, but
Yes.
when we open this, it's not activated. I
Yeah.
don't
So
know.
if you click on that BIP file,
Yes, it's not activated. You can see. QIM.
I mean the file itself. This is the result summary, right? If you open that file,
Yes, it open and it still it not showing. It's QIM. Assembly map. Okay, we can make in map chart figure.
When you go on your second tab, that RISE PIF, RISE F2 BIP file, the third tab, click on the third tab, not here in the results. Yes. No, not there. Yes, here now you can see those things.
Yeah. Yes, we can see that this way. Is still visible?
Yes, yeah, but map, the image is not there, what you have
Map it
marked.
is not showing.
Map is not showing.
Yeah.
Yes, this way we can see the map and the QTL
Yes,
on
yeah,
chromosome like this way in
right, right.
graph.
Yes, even for all the QTLs you can see at a time. Yeah, all the QTLs as well as all the markers, what if you want, you can see at a time. All the QTLs together.
Yes.
Traits, even traits also you can look at.
Yes, I know.
Mm-hmm.
You can't, but we have only one trait,
Mm-hmm. Yeah, just tell.
and this is the QTL mapping, and I'm getting the error, same error like in QTL doing when we are doing the RQTLs, and so we are not doing RQTL today. And if you want to do RQTL, we can discuss it on next week.
And one thing what, if you go back to that file, I see a mapping, can you open that? I just wanted to make a point there.
Okay. Yes.
Yeah, so here, you are doing this manual input, it is okay for demonstrational purpose, but when you want to get the actual effects and the actual phenotype variation as well as the associations, you must go for the permutation, which take a lot of time. So just I wanted to make that point. So there you will get the actual result, not in the manual input. So manual input is just you decide yourself that not with the permutations.
Permutation is mainly to understand significance.
Yes, so that's what I'm saying. So the actual significance and phenotype variation you will go through when you run for all the markers with permutation combination.
And mainly how to troubleshoot some assigning of the unknown markers to the
We
chromosome.
can just give it 0. If you don't
Zero.
have anchor information, you can just give 0. And then it will automatically when you
In the earlier I told that if you don't have the anchor information, you can give the 0. When I saw in the file,
Then the program will try to place that particular marker with 0 to each and every chromosome.
yes, it will place based on the recombination event or the linkage between them. It will give the linkage group to them.
even when you wanted to see, like, if you go through the rice map, it will show you like the distance between several markers. So you can see that even sometimes the long distances are there. So even you can delete, yeah, select a marker and delete, and then you can redo again so that you have the best linkage map. So here, so if
Yeah.
you see that the distance is very high, then there may be error in marker. So you can remove that marker. So when you actually start doing these are demo files, but once you start using your own files, you will see a lot of inversions and all those things. So you have to do a lot of editing in this. So earlier, like, in similar things we used to do like in map maker, right? DOS based or all this.
Yeah,
So
map maker,
map
ripple,
maker,
everything is there.
ripple function. You have to repeat, constantly repeat, use that ripple function so that you get the best linkage group. Similarly, here you have to right click and delete one marker wherever you find large distances, and then you will get a best linkage map. Initially, if you run, it may be like 3,000, 4,000, even 10,000 centimorgan map, which you should not expected. But once you do those combinations, you will see that. Yeah, just I
Yes,
wanted to make that point.
yes, yes. Nowadays we are using the SNP, and SNP are like 20,000 or 30,000. I think there is no gap between the too much gap between the marker. Uh, Earlier the people are using 100 SSR marker. There's maybe the gap like wheat genome is 17 GB and they are using only 100 or 200 marker. Then there is a gap between too much gap between the, but nowadays people are using SNP marker.
So even if you have SNP markers, what you need to do is that you first need to do the binning. And so what
Yes,
happens if your number of population is very less, let's say 100 or 2, 140 or something. Sometimes you will see the same profile for hundreds of markers. So then when you do the binning, then you again get that large distances. So through binning, you have to drop down that number, even if you have 180K
yes.
markers
Whenever
or
we are
50K.
doing the QTL mapping, we will select the only best
Yes.
we assume, and it's only based on the permutation or LOD score. Even if we see the old study like the SSR marker, they find the SSR marker in the same linkage group which are present on different chromosome. It's not possible, but they are getting
No, I
they
didn't get your point.
because they are the like the linkage disequilibrium means non-random association between the marker. There are many different things which will
Yeah, so
people.
earlier what you that the SSR markers, we didn't have locations, earlier
Yes,
days.
yes,
So that were just based on recombination frequency, not
yes, yes.
location. Now we know the location for all these SNP markers and all.
But we
So
know the physical position. We don't know
physical positions,
the
yes.
fetal mapping work on the centimorgan. There is the recombination event and
Yes, but
recombination.
still that inversion is not like, for example, if it is on large, what you say, mm, large fragment of the chromosome, right? So it cannot go like the short side. That what I
Yes,
mean
yes,
is that. So even if there are inversions, it cannot be more than like 1 centimeter, 5 centimeter, like that.
yes, yes. Based on
Yes.
based on the physical position and centimorgan, which give the best same orientation, we can select the linkage map.
Yeah. So when we wanted to do only based on like order, physical position, that's where the map of genome, like physical map, it gets bigger because we don't want to compromise there based on the frequencies. So if you
Yes,
want to compromise there, then markers will go here and there, and then you will get the shortest map. So both the things you need to judge based on the distances. That's what I mean. So you have to delete several markers after binning. So that has been my experience in soybean. So we used to get like initially 5,000, 7,000 centimorgan map, but once we fine tune them, then we will get like 1,800, 1,700, which is expected.
yes, yes.
So folks, any more discussion? So what we will do is, Virender, unlike we planned to take continuously. Every Sunday, 1 hour, we will have this session exactly like this.
Okay, sir.
Maybe for two,
Oh.
3 Sundays. So, Shravan, you can practice this at your place.
Yes, sir.
And then you have any questions, especially with your data, you can practice.
Yes, sir. Real time we will do
Right.
that one,
And
sir.
then
I
next
would
week
say.
you come back with questions. And also Virender will troubleshoot our QTL because it is corrupted on his computer. So he will update that and again come back next week.
Earlier we used your data, like you provided the data Foxtel Millet.
Yeah.
Yeah, fast later.
But in that time we are not got any type of this problem.
But
Mm-hmm.
always one thing or other happens. Easily
Yes.
these things get corrupted. And also, eventually I will teach map QTL of this giant map. That is expensive software.
Yes, but it's not available everywhere. It's
Yeah, it's we have
paid version.
lab, we have license, and then we can unofficially share that license with you all.
Oh, thank you, sir.
So you can secretly use it also. That is even more easier and faster. So
Yes, sir. Yeah, please give demo of that join map and map QTL.
yeah, I will give. I doubt I have it on this computer. I will check it if I have it.
Yes, join maps
Okay.
give more more confusion during making map chart. I know.
More convenient, more easy figures will come, tables will come.
Yes, it will delete more marker. I
But
know.
the stringency is so high.
Yes, sir.
Identifying a marker in these softwares is easier, and their even very QTLs that are less stringent are automatically eliminated. So we will get the best QTLs in Map QTL program.
Sir,
Okay.
we
Okay.
also wanted to know, like, the tools for conversion of the, like, coding and then conversion of the files. For example, like if you have a data file in like a snip file, and then we want, based on one parent or second parent allele, like A, B, or B, H, that
Okay.
type of conversions, or the other way around also. If you have A and B, and then if you,
Yeah,
uh,
if you have a VCF file, then it is easy to convert. Just 1 minute, less than 1 minute it will take. And you just need to install the tussle tool. I
Tassel, I do have Tassel, yeah.
Yeah,
Yes,
you
okay. I
do
can show
modification in
upload your
Tassel.
VCF file in Tassel tool, and then there is a format to change ABH format. You can change it. Now even now I can show you that thing.
Mhm.
Yeah, just show that one. Yeah,
Yeah,
that
that will be.
once you are getting sequence data, how you are going to format your data is also important.
Yes, sir. Yeah, according to your parent or even germplasm, like
And Virender, I have a question.
Yes, sir.
You know, the arsenic QTLs yesterday genes we have identified.
Yes.
Using that data, can we estimate epistasis on this?
That is not by parental populations we
It's
are
not
using.
biparent mapping, but you consider it as a, composite population.
Okay, so let's see. We can check. But we have other tool like P-Link. We can use the application P-Link and that MRMLM.
Okay, you try that also.
Okay.
Just with those genes, not the
Yes, sir.
whole
Okay, I
data.
know.
Uh,
Yes, now upload your file like this is the Tessel and
This is
upload your
Tassel.
file Tessel, upload open as and make it like VCF file, or if you have VCF or you have AppMap format, then click on this. Okay, but now I don't have any file, and it file once a file will upload it, it will show. Okay, I will upload any other file. And then click on data and click here the ABH format. You need to provide parent A information, one file containing parent A, another file containing parent B, and here is the output format. And just click and your file will come in your default folder where you want to save it, or it will be
What kind of file for parent A and parent B?
just name them, just their name.
So name means what is there in the
Yes,
that.
like this is the 88.
So 88.
88. And this is the suppose this is the parent A and this is the
Uh,
parent B.
yeah.
Just type
Can you give?
88.
Can you show that?
Okay, wait. I will make file.
Because I see the browse option, so I was thinking you have to have a separate file or what. So that's why.
Just
That.
wait. I will.
Mm.
Yes, file is saved here like this. I will show you. This is the file which I got as ABH 022.
How did you take that 88 and 108? That's what I didn't get.
I just type 88 in and only this thing.
So, no, I still didn't get. Like, just you made one notepad file with 108. That's
Yes,
it.
yes. You
Uh,
are not seeing, not able to see this 88 file.
no, I didn't see that.
Oh. And ABH file.
Yeah, ABS file I see.
Okay. Okay.
So this one you just made, or I wanted to understand that.
Yes, just made 88. I typed the 88 in notepad file and
Uh-huh.
10 another file 108.
And then you don't need that genotype information.
No, genotype information already in
HapMap file. Okay.
yes. I think I'm getting this the wrong file because it only give 1, 2, 3, 4, 10 SNP information.
Mm-hmm.
Yes, that's why I'm not sure about this. Maybe
Yeah,
I
I
need
was thinking like you need that complete information
separately. I think separately
for
for both.
two parents, so
Yes,
saved separately,
yes,
and then you load them. So that probably will help. That's what I was thinking.
yes. I thinking also. Last time I changed, but I don't have example file now. But that is the method. You can try this way. Change. Just click go to ABH genotype and change to your file format.
Okay, thank you.
Okay.
So, folks, if you don't have any questions, you practice this and come back next week.
Yes, sir.
So,
In real version, we will do that one, sir, and then if anything doubts also, maybe we'll mail in between, sir, to you so
yeah,
that yeah,
mail in between to me or Virender. I will share Virender's email. You have it,
sir.
I think. Then next week we will discuss if there are any gaps,
Yes, sir. Yes, sir.
especially for Shravan. So instead of
Yes,
taking continuously, because for Virender it is lunchtime, he didn't have breakfast today. He is
Okay.
probably running out of energy.
thank you, thank you. And sorry, Virender.
No problem.
Huh? Okay, then,
Yeah.
all right. Have a great
Okay.
week.
Yeah. So please see this one also. Sort out this, and then we'll see
Yeah.
like conversion also.
So I
Okay,
will
I
send
will just.
again.
Mhm.
I will tell you. Don't worry.
Thank you.
Last
Thank you.
time I changed my file by
Uh,
TESL.
yeah. Next meeting you can show. No problem.
Okay,
Thank you.
okay.
So single
Yeah.
sitting, it is everything is kind of
Correct,
crammed
sir.
up.
Yeah.
So it's better to come back again.
Yes.
No.
Sure, sir.
Okay, sir. Okay, sir.
Thank you so much.
Thank you, Virender. Yeah.
Okay, okay.
Thank you.
Welcome.
Thank you. Thank you, sir.
All right. Thank you. Take care.
Bye.
Bye bye, sir. Bye bye, Virender. Have a
Bye.
nice weekend.